Hi guys, welcome back to our lesson. So we are still looking at functions, right? And this is mainly just to revise those functions. So now we're going to look at a hyperbolic function just to revise what it is about, and an exponential function just to revise as well what it is about. And then remember as well, at a later stage we'll look at some more questions that have to do with past papers that are asking the same questions under functions, but from the exam type of situation. So let's have a look at it. Now, a hyperbolic function, as we can remember, this is a function of the form f of x is equals to a over x plus p plus q, and we know that the p and the q are the asymptotes of the graph, which are normally shown using a dotted line like this, right? So where the P is the vertical one and the Q is the horizontal one. And this graph is normally called a hyperbola. Now, the very first question will be to sketch this particular graph, right? And to sketch this graph, you can already see that this graph is a negative there. Now, for it to be a negative, we need to quickly see what that does for us, right? If a graph is a negative, firstly, I will start with it as a equals to 1 there, as you can see. As soon as I make it a negative, it changes where it was in terms of the quadrants. It is now in the second quadrant and the fourth quadrant because of the negative. So already that gives us the idea where we are going to place our function. The value of p, if I move it to be a positive, you can see this simply means that it is shifting. Okay, so this is actually supposed to be plus there because we use a plus. So if I am shifting this that way and making it a positive, I am actually shifting it to the left-hand side. And as soon as I make it a negative, I then shift it to the right-hand side. So with the function that we have, let me quickly just check. It was a minus, so it means it's to the right because it's now a negative. So it will be minus 3. Let's make it minus 3 there. And this is also negative 3, so I'm going to put it there. Nope, just minus 3. Yes. And then we also have the value of q, which we quickly need to check as well what it is, which is 1, right? It must be a positive 1, so it means I'm taking it 1 unit up. So that becomes there at 1, and that's what my function will look like, right? So it was the original function which was at the center, and it being the center meaning the origin, right, on either side of the origin. I then reflected it about the y-axis, where it then changed the sign and it became a negative, which is the second quadrant and the fourth quadrant. And then I shifted this 3 units to the right and then 1 unit upwards. So to answer the question, sketch this particular graph, it means our graph will then look like this. Now, you can see that on the diagram I did not show the asymptotes because I wanted you to see how to actually do that. So you will take your ruler, you can see that at positive 3, because it was moved 3 units to the right, that's where the first asymptote will be. So you're going to draw a vertical line, dotted line that is going down that way to indicate the vertical asymptote, and then positive 1, which will be a horizontal line like that. And that's where our asymptotes are going to be. So you'll write here x equals to 3, and then here y equals to 1. And then what are the equations of the axis of symmetry? Remember, axis of symmetry have to do with when you are trying to find the line that cuts the graph into 2 halves. So we normally use y is equals to x plus p plus q, right? So that's the first one, and then the second one is normally y is equals to minus x plus p plus q, right? So that's what you just need to look at there. So it means this is the same as x minus 3, because our p there is minus 3, plus 1, which is equals to x minus 2. So that's the first equation, right? And the reason why it has two equations, I'm just going to show you now on that particular graph that we first drew. This one will be y is equals to minus negative there, just to work it out, x minus 3 plus 1, which is the same as negative x plus 3 plus that will be plus 4, right? So just remember these two graphs, because I want to show you what this means on the graph, x minus 2 and minus x plus 4. So remember we said it's y equals to x minus 2, right? So you can see this line is definitely cutting this graph into two halves, right? Which is the part below it and the part above it. Then the second line was y is equals to negative x plus 4, right? So the same thing, it is passing through where it looks like it's the center of the curve that we have, right? So we normally have two lines of the axis of symmetry of a hyperbolic function. So please do note that. Now write down the asymptotes of f. To write down the asymptotes of f, it will be x is equals to positive 3 and then y is equals to 1. And remember, where I get the positive 3, it's x minus 3 equal to 3, and then you solve for x, which then gives me a positive 3. The domain and the range, the domain is that firstly my x cannot be equal to 3. We know that. But x can be anything else, meaning it can be an element of real numbers provided it is not equal to 3. Also the range, y cannot be the asymptote, which we agreed that was 1, but y can be all the other numbers that are on a Cartesian plane. With the exponential function, remember this is a function in the form of ab to the x plus q, where a, b, and q are the constants, and the exponential function normally has only one asymptote at most, right? So it only has one asymptote. Now to sketch this graph, I'm gonna go back again to my simulation that side, just so that you can see what an exponential graph looks like. Right, so if I move around with my values here, I started with a as 1. If I make a bigger, you can see this becomes a bit steeper, or it becomes a bit stretched, right? It gets stretched a bit more. And then with the b value as well, as it becomes bigger and bigger, that's when it is becoming more increasing. If it becomes a negative, then you know that will not be a defined function, but we know that it can always be between 0 and 1. So it must always be greater than 0. And then the q value will be our horizontal asymptote, but the p value is just a constant. It doesn't tell us anything about what the graph has to do with in terms of where we can locate the graph. So this will then be, to sketch this graph, this is my horizontal asymptote, so I will immediately by -2 draw a dotted line. This is a positive, so it means it's an increasing function, so my graph will look something of that nature, just a rough sketch. But in actuality, it will then look like this, where at this point, that's where my y equals to -2 will be, with a dotted line. And then also, if I'm given this function, the asymptotes of this particular function of mine, we know that will be y is equals to -2, because there's only one asymptote, which is the horizontal one. The domain and the range of this, the domain, definitely x can be anything and everything in terms of the real numbers. So x is an element of real numbers because x can be 0. If it's 0, it means it's 0 plus 2, which is just 2, right? But with the range, this y cannot be minus 2. And it can also not be below minus 2 because remember that minus 2 was there and the graph is above minus 2. So it means y is greater than negative 2, and that will be what this graph is all about. So we need to understand that the domain of a parabola and an exponential graph will always be x is an element of real numbers, but with a hyperbola, as you saw, there's two asymptotes. So the first asymptote will be what we talk about in terms of the domain, and then the range normally differs with all the functions depending on what function you have. But here specifically, minus 2 is not part of the range, so I can't include the bar. It can only be greater than negative 2, and that's how you then answer or write down the domain and the range of this particular graph.